morning, everyone. Today we are going to deal with the things of safety measures. And these are the different contents you have to learn. Working principle of fuse, miniature circuit breaker, and the merits and demerits, personal safety measures from the electrical shock, earthing and its types, safety precautions to avoid shock. Let's start our session. Yeah. What is meant by this electrical fuse? It's just a safety device to limit the current in an electrical circuit. The electrical fuse protects the circuit from the damage while exceeding current or voltage fluctuations. It's just the protective devices here. In this, we can have some different fuses there. It mainly works on the principle of heating effect of electrical current. That's nothing but Joule's law of heating. It is placed in series with the device. Don't neglect the things. It works on the principle of which thing? Heating effect of electrical current. And we can observe what's the definition of this fuse here is. It is inserted in the circuit and melts when the current passes through it exceeds its rated limit. Let it be you are having some 5 amperes. If it exceeds 6 or 7 amperes means it can melt it out. And we can have some low melting point for this fuse material. The fuse material depends upon different things. The material may be tin. The melting point is approximately 450 degrees Fahrenheit, or else lead melting point is approximately 621 degrees Fahrenheit. Lead and tin alloy combinedly, we can use it also there for extreme high temperatures. It's approximately 350 degrees Fahrenheit there. And the main fuses are designed to melt quickly when the current exceeds a certain threshold, protective electrical circuits from damage caused by overcurrent or short circuits. These are the different symbols here. Fuse may be used in a symbol like this. These are the different components we can easily observe in internet source here. And observe this fuse material. It's nothing but we can have some filling powder fills the internal space of fuse body. The filling powder materials used in the fuse are quartz, plaster of Paris, dust, marble, and chalk. This one. This one is fusing material. It's nothing but a tin, lead, or a combination of both. This one is a brass and cap. We can easily observe yellow color type in our household or black color. If it can exceed some limiting temperature, limiting current, it can fuse will blown out, and we can protect our household appliances. Yeah, it mainly depends upon heating effect. It's made up of thin metallic wire, which is non-flammable and has low melting point. Don't forget that line. These are different materials normally used: zinc, aluminum, copper, and silver. The function of an electrical fuse is to protect electrical circuits and devices from excessive current or short circuits. It is a safety device that acts as a sacrificial element in the circuit. Some of its main functions are: it can act as a potential protective barrier. It safeguards against device failure. The fuse prevents short circuits. It helps prevent overloads and blackouts. Advantages here is these are the different advantages. It's a low cost, easy to replace, simple and reliable, protect circuits and wiring. Disadvantage here is manual intervention is required as there is no automatic reset. Components can still be damaged in the short time before the fuse interrupts excessive current. Fuses completely interrupt power to the circuit. A single fuse protects an entire circuit. If it fails for any reason, the whole circuit loses power. These are the different disadvantages of electrical fuse. And in order to make some advantages uh, overcome that faults what we can have in the fuse, we go for the next one here is circuit breaker, that too miniature circuit breaker. We may call it frequently as MCB. It is also another safety accessory here, which can mainly use some electromechanical mechanism of action. It's just an automatic switch that opens when excessive current flows through the circuit. It can be reclosed without any manual replacement. This one is the drawback we can come across and fuse. It can be overcome by MCB. MCB stands for miniature circuit breaker. This one is you can come across this type of MCBs in the household. Yeah, observe the working principle of MCB here. We can have some two protections: overload protection and short circuit. What's that overload protection here is? Just observe. They can use some bimetallic strip here, which is made up of bimetallic means two metals you have to choose. One of the metal here is copper and the one is steel. We can combine those two things there. Observe the things. Under normal, we can have some phase and neutral like this. Bimetallic strip, trips bar, load. This one is a contact, closed contact. In the normal conditions, observe this one lines here. The current passes from phase to bimetallic strip and then closed contact to the load and neutral under normal conditions. For the sake of protection, overload condition is there now. Under the overload condition, current passes from phase to bimetallic strip and it can bend that one towards the part of the strip circuit. Enlarges like this. Why means we can choose some bimetallic now. When there is some overload is there, it can bend towards the part of which thing here, bend towards the part of this one here, and it can bend, it can open out. No current will flow, and obviously this load is safe. This one is the protect. This one is the equipment we can use it safely there. When there is an overload, this bimetallic strip bends. It can gives to the trip bar, and there is no connection to the part of which thing this load. This one is a overload condition. Just write these two lines, that's enough. We can have some bimetallic strip, trip bar, load. That's it. Same, going for the part of another condition, short circuit condition. In that, we have some different components, same phase neutral and load, but in between the things, we can have some solenoid, having some coil like this, plunger, contact, trip bar. Yeah, under normal conditions, current passes from phase to contact and towards the part of the yellow lines to the load. And again neutral like this. Whereas in short circuit, if there is any excess current, it passes towards part of phase and it can magnetize this particular solenoid and this current, we can create some magnetic field here. And this magnetic field will attract this plunger. This yellow colored one will attract towards the part of this solenoid magnetic field here. It moves towards the part of this side and it can open this contact. Open circuit will occur and plunger hits the part of which thing trip circuit, this one, and MCB will switch off. That's the only line. Just we can create some magnetic field under short circuit and it attracts this plunger towards part of this one and it can disconnect this contact now open and the MC trip bar will activate and we can protect this load. My intention is I would like to protect our loads. That's the main thing. Yeah, that's only some theoretical matter. These are the different advantages and disadvantages. MCBs have more sensitive material. It has quick work against short circuits, overloading and under voltage. It is reusable and less maintenance cost and less replacement cost. It is very simple to resume the supply. It can be easily used in a circuit control switch. It has reliable, better interface, everything. All these are different advantages of miniature circuit breakers. Disadvantage point of view, the cost of MCB is somewhat higher than fuse. The cost of MCB distribution board is greater than the revariable fuse board. The risk of overloading of the circuit due to unqualified personnel cannot use this one. Why means there is some logic behind the part of MCBs. Yeah, these are the advantages and disadvantages or merits and demerits. This one is one more differentiation in between MCB and fuse. MCB trips off in case of excessive load, whereas in fuse melts in case of excessive load. MCB is to be just put on after correcting the faulty in wiring. Fuse needs to be replaced with a new one with the personal intervention. Since we do not change the MCB, there is no risk of putting on the MCB switch, even if the fault is not correctly repaired. There is a risk of putting on the switch in case. It's just a compact and small equipment. Porcelain base and top, not attractive. Works on a bimetal expansion or induced magnetism, that it is solenoid or bimetallic strip, with the help of copper and steel. Works on the melting and fusing due to the high temperature. Relatively cost of, it's just cheaper than MCB. These are the different differentiation in between MCB and fuse. And coming to the personal safety measures, what is meant by electrical shock and precautions? Electrical shock is a sudden discharge of electricity through a part of the body when a person comes in contact with the electrical equipment. When it touches an electrical equipment, sudden discharge of electricity through a part of the body when a person comes in contact with the electrical equipment. The factors affecting the severity of shock mainly depends upon magnitude of the current through the body, path of the current through the body, time for which current is passed through the body, frequency, physical and physiological condition of the person. If the person is weak, it can obviously the high amount of shock will be there. If the person will have some high resistance, less amount. That's the only thing. Precautions to be maintained against electrical shock. Avoid water all the times. Never use equipment with damaged insulation. Earth connection should be maintained in proper condition. Use of fuse and cables of proper rating. Use the rubber soled shoes. Mega test has to be done. Never touch two different terminals at the same time. Never remove the plug by pulling wire. The socket should be replaced with a proper height. Switch off supply and remove the fuses before starting the work with any installation to avoid shock. Always use insulated screwdrivers and line testers. These are the different precautions you have to maintain against electric shock. Yeah, and the next one here is earthing. And what's earthing is nothing but just observe this definition. The process in which instantaneous discharge of the electrical energy takes place by transferring charges or electricity directly to the earth through low resistance wire. The process in which instantaneous discharge of electrical energy takes place by transferring charges directly to the earth through low resistance wire. And the necessity here is to protect human beings. It guarantees the safety of electrical appliances. It protects appliances from high voltages and lightning discharge. It provides an alternate path for leakage current. It keeps the voltage constant in the healthy phase. It avoids the risk of fire to maintain the line voltage constant under unbalanced load condition. These are the necessity of earthing. And this one is the definition. And we are having some different purpose of electrical systems here for the earthing. Safety wise, equipment protection, lightning protection, electromagnetic interference reduction, the EMI reduction. All these things can happen only if you can maintain some earthing properly. And we have to go through that earthing wise here. Just observe. We can place some lightning arrestor via some wire here like this low resistance wire. If there is any lightning occurs, the lightning arrestor will catch that one and it can bypasses that entire household and it can passes through the low resistance path towards the earth. This one is a simple diagram we can observe. And how we can make this earthing everything, we have to learn like this. There are three types of earthing here: pipe earthing, plate earthing, strip or rod earthing. The first one, pipe earthing here. Pipe earthing is the best and the most efficient way of earthing here, and it is also affordable. Pipe earthing uses 30 mm, 38 mm diameter and 2 meters length pipe vertically embedded into towards the ground to work as an earth electrode. And we have to make it one entire pit again surrounding this particular earth here. When I can place some plate here, we can have some salt, sand, everything we have to go, cover it out there. That one is also one more thing. Filling that entire house. A pit is dug in the ground to the house, the earthing plate. The depth of the pit varies depending upon the soil conditions. Next one, plate earthing. In plate earthing, we can use some earthing plate made up of copper or else galvanized iron. Is buried into the ground at the depth of 3 meters from the ground level. This earthing plate is embedded in an alternative of coke and salts. It's nothing but GI stands for galvanized iron. And the next one, rod earthing. In this rod earthing, only replace that plate with the help of galvanized steel is used. And don't forget, in order to fill out that entire earthing material here surrounding the part, we can use some layers of charcoal and sand. This combination helps to retain moisture and enhances conductivity. Don't forget that one. This one is a pipe earthing. Directly they can insert some file. And the surrounding of this one, we can have some salt, charcoal, coal. This one is a pipe. Same for the part of plate earthing. We can insert some plate here. Diameter, we have to maintain that one. Surrounding the parts, coal, salt, sand. This one, same. This one is a copper strap. We can use some galvanized iron pipe like this. You can choose it from the internet source. Yeah. These are the different earthing types. Thank you. Thank you very much.